You see problem 2, rigid body kinematics 1. Gear A of the winch, turn gear B, raising the hook edge. Gear A has a clockwise angular acceleration alpha A equal to 2t radian per second square. What is the upward velocity of the hook at t equal to 2 seconds? So this problem is a little bit not explicit about what is the initial condition, but they say at t 2 seconds we can imply that initial condition is t0, it will be at rest. Okay, so they give us the body properties and they ask and the acceleration and ask the velocity. So before we do anything, we have to ask the question that I raised earlier in the problem 1. The first is, does the problem give point or body properties? Give point or body? Alpha, so which is body properties. And then if it body, then the next step you need to find out is the point. We will talk about that later on. How many rigid body? In this case, you can consider 2 or 3, right? Gear A, gear B, and you can consider the hook in another body. So 3 bodies. If you don't consider the hook, you consider that attached to the gear, then it can be 2. But let's talk about 3 bodies in here. And if 2 or more bodies, we need to ask yourself, where are the common points between the body? So what are the common points in here? So let's take out of that. Figure it out. The first common point between gear A and gear B is the touch between gear A and B. I call that here point C. And then the second common point that here is between the hook and gear B. So those are the common points you have. And let's talk that point is point D. So the next step, when you have 3 bodies, you need to classify what type of motion. And you can see gear A and gear B rotate about the axis, go through A and go through B respectively. So that will be a rafa. So the classified motion. So A and B, it will be rafa. Gear A, rafa. Gear B, rafa. And then the hook, just as you can see, hook HD just go vertically. It's not rotation, and that with that is we can consider that here translation. No rotation here, so body is translation. And when it translation, any point on the body will have the same velocity, same displacement, same acceleration. So the question asks, what is the velocity of the hook? So what we have here, it will be VH equal to VD. Because on the same translation body, every point have the same. D belong to the hook, H belong to the hook and the rope there. So they have the same velocity. So if the question asks what is velocity of the hook, then we can find out through the velocity point D. So let's go back to the problem and start with here. They give us alpha. So we have alpha equal to alpha A of the gear A's. Let's talk about gear A. So let me put that here so that it not confuse. Gear A, GA, and equal to 2t radian per second square. Before we go to step, find out the point properties, we need to find out the omega first, right, to complete with what they already give us. So alpha, so we have omega of the gear A is equal to integral of alpha t, integral of 2t alpha dt, so it's 2t dt, and equal to t squared plus c1, if you recall that initial condition. So at t equals 0, we have at rest, right? So you have omega GA, the angular velocity, equal to 0. So it equal to 0 squared plus C1. So you have C1 equal to 0. So from that I can have, and then I can have also at t equal to 2 seconds, we have omega GA equal to t squared equal to 2 squared equal to 4, and the units equal to radian per second. So now we already have the body properties for both. The next step, we need to find out the point properties. What point properties? You cannot jump from the gear A, which is given. Start with what is given. Given is gear A. You cannot jump to the point that they ask is H or D. We need to find out the common point. And that is very important here. Where is are the common points? As you can see, we just do one step at a time. A is gear A. So body property, find out another point properties, and that should be a common point between gear A and gear B. So as you can see, should be a point C that we have it in there. So the next step here, we can say from body property of gear A. So A here is the whole body based on this problem. 2 point property, and in this case the common point of the two body, point property C. So from body to point, So how we can do that? You see a Rafa motion. You should go ahead to draw the Rafa stick for this problem. So we have the gear A, and C, the point that we want to find out, C, and we want to find out the velocity of point C before we jump on to gear B. So need to find out the properties for a common point. Let's talk about here. As you can see, 4 radian per second of the omega GA. Whether it's clockwise or counterclockwise, it's very important. We need to find out. Okay, there are two ways that you can find out omega GA direction. The first one, they say the hook edge raising up. You can see the hook edge raising up. Here, raising. Then D also raising. So you can see that velocity VD the same as VH, so it's raising. When VD raising, D belong to gear B, then gear B have to rotate counterclockwise to be consistent with VD. So omega GB, right? And when omega GB go to counterclockwise, common point C belong to also gear B. So have to be consistent with the omega GB. So then the velocity have to going down. VC. And when the velocity C going down, C also belong to gear A. Then the omega of gear A have to be clockwise to be consistent with VC. So you see that? So they give you raising up the hook. Then VD go up, omega GB, it will be counterclockwise. Then if it counterclockwise, common point C also belong to gear B. It will be going down vertically. When it going down, if we look at the gear A, VC going down, then omega GA have to be clockwise. That is the first. The other, they give it here. Gear A has a clockwise angular acceleration. So that one here, we can write that is a clockwise. And as you can see at time t0, clockwise 2t omega equal to t squared. See, and it should be increasing 2t, alpha is 2t, t from 0 to something positive, so alpha is positive. So that means it increasing speed or accelerating for the gear A. So when it accelerating, the alpha and omega have to have the same direction. So if it clockwise, then that have to be clockwise. So keep that in mind when we have it before we continue. So reason ourselves. What is the direction? Very important. So now let's continue to do graphastic for here. So that one here. So we have alpha and omega clockwise. So we have it omega GA. Actually, we don't need even draw the omega alpha GA. So that one equal to 4 radian per second. And then when it's 4 radians per second, as you can see, it have to consistent with the velocity VC going down, VC going down, and then the radius of AC, if they give us here, should be 50 millimeter. So you have, let's write down separately here, C relative to A is 50 millimeter. So from that we can go ahead to find out VC from the body properties omega GA. So we have VC equal to omega GA of the gear A times the radius of C relative to A. So we can have 4 radian per second times 50 millimeter. So we have 200 millimeter per second. 200 millimeter per second, and just going down, then we have go down, we see. And when you have the point property of common point between gear A and gear B, then you jump to gear B. So as you can see, start what is given is gear A, body properties of gear A. Then you find out the common point properties, common point here C. So find out VC and move on to the body properties of the next bodies, and that we will discuss in the next step. In here, move from point C properties to body property of gear B. So let's write here. So from point C property, which is common point, right? Property to body property. Which body? Gear B. So don't jump, one step at a time. Gear B. Keep that in mind. The gear B is the whole body, which is the gear, not only one point B specifically at the center of the gear. So keep that in mind, and we will continue to solve this problem in the next video.